In this video, we are going to begin by talking about the action potential. In the previous slide, you learned a little bit about graded potentials. Action potentials are quite different. They are what we call all or none, which means that every action potential looks exactly the same. The action potential is a brief change in membrane potential in a local patch that is depolarized by local currents. So this graph is showing that during the course of an action potential, voltage changes over time at a given point within the axon. And it's very important to remember axon because that's where action potentials occur. It's only in the cell body and the dendrite where the graded potential actually occurs. So let's first look at the key players down here, some of which you've already seen. So there are voltage-gated sodium channels, which have two gates and alternate between three different states. There's sodium channels, and then there's also voltage-gated potassium channels. So there's no ligand or chemically gated channels. Those are only for graded potentials. So initially, the gate is closed, the sodium gate is closed, so no sodium is entering from outside the cell to the inside the cell, which is the intracellular fluid. Then, when the gate opens, sodium then enters the cell from the extracellular fluid to the intracellular fluid. Then the gate becomes inactivated, so that and that's soon after it opens. But during this process of these events, we see number 2 occur on the action potential graph. It begins at the resting membrane potential, which means no ions are moving through voltage-gated channels. The sodium and the potassium gates are closed. Then in number 2, we have sodium influx because those voltage-dependent sodium gates are opening. Then we also have potassium voltage-gated channels, and you'll see they are also closed at the resting state. But when they open after depolarization, and that's important to remember, it's at the end of depolarization. So once depolarization begins, at the end of it, these potassium channels open and potassium exits the cell. So number 3 is potassium efflux, called repolarization. And that means that the membrane potential inside the cell goes from plus 30 down back towards threshold, and then it continues past threshold because we have a slight period of hyperpolarization because more potassium leaves the cell. Remember, you learned that there are more leakage-gated potassium channels. So that's why we have a period of hyperpolarization. In the right side of the slide, we see these events also, which are showing each of the states. So we have the resting state here, where the gated sodium and potassium channels are closed. Sodium has not entered yet, so we can see that we're still at number 1, at the resting membrane potential, which is negative 70 millivolts. The first phase of the action potential is shown here, which is depolarization. And here, sodium is going to enter the cell. So we see this event occurring right here. Potassium hasn't left the cell yet until we get to step 3, which is repolarization. The sodium channels are now inactivated, the potassium channels open, and potassium exits the cell. And again, since the membrane is more permeable to potassium, those gates remain open and we see a slight hyperpolarization. Hyperpolarization essentially means that it continues from negative 70 to negative 90. So in step one, we're still at negative 70 millivolts. In step two, we go from negative 70 to plus 30. In the repolarization phase, we go from plus 30 to negative 70, and then we have the hyperpolarization that is shown. So those are the steps of the action potential. Now, as an action potential propagates, this is exactly what is going to occur. This would be voltage at 0 milliseconds. It's not yet recorded. It's not yet reached the recording electrode. Then at 2 milliseconds, the action potential reaches the recording electrode. So we have the upswing of the action potential. And then as it continues to spread further down the axon, we have the downswing of the action potential. So we can see that the action potential begins at one part of the axon, and then it continues downwards to another part of the axon. And then again, when we have myelin that's wrapped around the axon, we have action potential essentially leaking or leaping rather from node of Ranvier to node of Ranvier. So remember, the threshold is typically when the membrane is depolarized by 15 to 20 millivolts. So usually it goes from negative 70 to about negative 55 millivolts. So if it's a weak potential, we call that subthreshold, and that would be the graded potential that you learned about earlier. However, action potentials are very strong, so they meet threshold, and as soon as they meet threshold, they're automatically relayed into an action potential. So the sodium ions influx exceeds the outward leakage movement of potassium. So it's a self-propagating activity. And because of that, we call this the all or none phenomenon because every action potential looks the same. And as long as it reaches threshold, that magic number of negative 55 millivolts, we have an action potential. So the threshold is almost like the jumping off point, and it's also the point of no return. There was an old movie called Thelma and Louise, where both Thelma and Louise were in a Corvette. And there was a point in the movie where they actually jumped off of a cliff. That was the point of no return, the jumping off point. That is like an action potential. Once sodium ions go into the cell, it depolarizes to negative 55 millivolts. So let's look at how this happens at a synapse, which we will be talking about next. But the end of a neuron is the axon terminal, and there's another membrane where there is a ligand-gated channel. So the neurotransmitter is going to be released here. That neurotransmitter is going to bind to a ligand-gated channel. That is called a graded potential, which you've learned about, and that's going to be on cell bodies and dendrites. However, what we just discussed was an action potential, and the action potential is going to go on only on the axon. So I'm going to just zoom in on this part, and then I'll zoom back out. But imagine that this is the part of the neuron where the cell body is, and we have this large axon, which is leading away from the cell body. That is called the action potential. So again, the part of the dendrite or part of the cell body is where we have graded potentials, but it's only in the axon where we have this all or none action potential actually occurring.